Welcome to Review Recording 1A, B, C to accompany instructional recordings 1A, 1B, and 1C for Section 5.1, Unit 5, Chapter 5 of Mathematics 2200. We'll do examples about converting from mixed radicals to entire radicals, radical expressions containing variable radicands and the restrictions, comparing and ordering radicals. Example 1. Express as an entire radical 4x cubed y squared times the square root of 5xy. First thing we look at is what is the index on the radical. So we notice it's a square root, so really we're talking about an index of 2. We want to bring the coefficient of the radical under the radical sign. Therefore, we have to express that coefficient as a power of the index. In other words, we have to square it first before we can bring it under the root sign. So we've got the square root of 4x cubed y squared all squared times the radicand that was already there, which is 5xy. Squaring the 4, we get 16. X cubed squared, we've got to multiply those exponents, so we've got x to the 6. Y squared squared is y to the 4 times 5xy, and now we multiply out what we have. 16 times 5 is 80, x to the 6 times x to the 1, that'll be a total of x to the 7 when we add those exponents, and y exponent 4 times y exponent 1 will give us y exponent 5. In example 2, we're asked to determine the expression that has a restriction of x less than or equal to negative 1/3 on the variable. First thing we look at is the index. In this case, we have an odd index. If there's an odd index, then we have no restriction. So we have the same thing occurring in both of these. The index is odd, therefore no restriction. So we rule those out. They're gone. So the only ones we have to check on are C and D. The index is even because it's a 2, so they have restrictions. Let's check option C. A radicand must be greater than or equal to 0. So therefore, 6x plus 2 must be greater than or equal to 0. Switching that around, 6x is greater than or equal to negative 2. And we divide both sides by 6. And we get x greater than or equal to negative 1/3. So that doesn't fit the bill. Let's do D. Let's see what happens there. Again, our radicand must be greater than or equal to 0. So we've got negative 6x minus 2 greater than or equal to 0. Negative 6x greater than or equal to 2. We divide both sides by the negative 6. But when we divide by a negative, we have to change our direction for inequality. So we wind up with x less than or equal to negative 1/3. Therefore, C is incorrect, D is correct. Example 3. Write in order from least to greatest by expressing as entire radicals. Beginning with 2 cube root of 25. Before we can bring that coefficient of 2 under the root sign, we have to express it as a power of the index being 3, so it's 2 cubed, times 25 with it, and we have the cube root of 8 times 25, which is the cube root of 200. The 6, that's not under a root sign, but we want to compare it to other cube roots, so we have to express it as the cube root of something. It's the cube root of 6 cubed. The exponent has to be the same as the index. So we've got the cube root of 216. Meanwhile, 4 times the cube root of 3. That gives us the cube root of 4 cubed, expressing that 4 is the power of the index, times 3. So we've got the cube root of 64 times 3, which is the cube root of 192. So that's the smallest one so far. Next we have 5 times 2 exponent 1/3. Remember, when we have a fractional exponent, the denominator in the fraction is the index in the radical. So I actually have 5 times the cube root of 2 here. Now I want to cube that 5. In other words, give it the exponent that is equal to the index times the 2. That gives me the cube root of 125 times 2, which is the cube root of 250. In the last case, we've got 27 exponent 1/3 times the cube root of 6. That 27 exponent 1/3 is the cube root of 27 times the cube root of 6. We can go ahead and multiply the 27 by the 6 because they both have the same index on their radicals. And 27 times 6 is the cube root of 162. Therefore, this one is the smallest. The next smallest is this one. Then the next smallest is this one. Then this one. Then this one. Therefore, we write them in order in their original forms, like this. Key ideas. For radical expressions with an even index, the radicand must be greater than or equal to 0. But notice it's with an even index. If it's an odd index, there's no restriction. When converting from mixed to entire radical form, first express the coefficient as the power of the index, place it under the radical sign, and multiply by the radicand.